Good morning, everyone. Okay. I hope it's audible. Okay, fine. So we have been working on a few of the numericals related to springs. Many students had queried as can you solve some problems based on springs? So because they usually get confused with the whether to use the force equation, which is your F equal to kx, or the E equal to half kx square when we start solving problems. So I took up one more problem, HC Verma. So this is like this. Initially, the spring in the figure. Oh my God, this figure is missing. Okay, let me write down the figure. Spring in the figure shown below is unstitched. Okay, the figure looks like this. There is a pulley. There is a spring which is connected here to the ground. This is the ground. And on the other side, you have an object of mass m. Of mass m. This is the figure actually. Okay. Now what happens is, so when you add a mass here, then what will happen? So this spring will now start elongating. So as a result of it, initially when there was no mass, might be the spring length could have been so much. Could have been so much. Okay. Now because of the addition of the mass, might be the spring length has increased by this much. Let us say this is x. Now the question is, what is the value of x? Now how do we solve it? So most of them, they assume an approach like this. So when you add a mass, definitely this mass will pull it like this. As a result of it, mg is the force downwards, t is the force upwards. Now there is no acceleration, net acceleration is 0, because you see object does not move. Okay, it stops there itself. Just a moment. Okay, so therefore when you add a mass here, there is an extension in the spring as you observe here. So what we do is we arrive at a free body diagram. So the free body diagram tells you that mg minus t equal to 0 or t equal to mg. You can directly write t equal to mg here. T equal to mg. The same tension acts here also. So this tension should be equal to the kx, the Hooke's law, right? So tension is nothing but the applied force. This should be equal to kx. Now equating these two, we get x equal to mg by k. Okay, appears to be reasonable, no flaws, nothing. But this solution is incorrect. So why is it incorrect? Or why shouldn't we apply this t equal to kx here? And what should we do? So this is the misconception that we need to look at. Now, first thing is that when you write this t equal to kx, okay, and also you write t is equal to mg. See, you have written two equations, right? From this equation, you have written t equal to mg. Here you have written t equal to kx. Now you observe t equal to mg is nothing but a constant force. And you observe here, this t equal to kx is a variable force. So you should not equate a constant force to a variable force, which is incorrect. Okay. So as a result of this, you should not use this rule. Now, what rule should I use? The simplest rule that you use here is that when you take the mass and put it over here, okay, what happens? So when you attach it, the mass does not stay here. At t equal to 0, mass is here. The moment you leave your fingers, then what will happen? The mass will now start coming downwards. Okay. The mass now comes downwards. Now, when the mass comes downwards like this, the center of mass is shifted by the same distance as which the spring has been extended, right? So the mass has moved by a distance x, spring has moved by a distance x upwards, and this has moved by a distance downwards. So that means there is a change in the potential energy of the object. Do you agree? Okay, there's a change in the potential energy of the object. So therefore, now you can always say that mgx is nothing but the work done by the object, because you see mg is the force acting downwards, x is the displacement which has acted downwards. So therefore work done is equal to mg dot x. Okay, so what is mg dot x? Mg dot x is nothing but mgx cos theta. What is theta? Theta here is 0. So therefore this is 0. Thus it is mgx itself. Mgx itself. This mgx should be equal to. Now what has happened? You have done some work. Now at the expense of what? Some energy has been given, has been stored over here. So this energy is nothing but the spring energy, which should be equal to half k x square. Okay, half k x square. Thus what I can do is I can cancel this x over here, and thus I can write. What do I need? I need to get the value of x. So x should be equal to 2mg divided by k. This is the right solution. Okay? Okay, fine. Thank you, friends, for watching this video. If you like more, do subscribe to my channel. Thank you for a good response so far being seen. Like and subscribe to my channel for further updates. Thank you.